Hello everyone, I am Dr. Octet. I welcome you in my YouTube channel. Today in this video, I am going to talk about shapes of molecules, and I hope this video will be beneficial for you. The shapes of molecules, depicting molecules and ion with Lewis structure, using Lewis structures and bond energies to calculate heat of reactions, valence shell electron pair repulsions, Curie and molecular shapes and molecular polarity. The steps in converting a molecular formula into a Lewis structure. Molecular formula, step 1. Atom placement. Place atom with lowest En in center. Step 2. Sum of valence electrons. Add A group's number. Step 3. Remaining valence electrons. Draw single bonds. Subtract 2 electrons for each bonds. Step 4. Lewis structure. Give each atoms 8 electrons. 2 electrons for hydrogen. This is the step 1, step 2, step 3, step 4. Now molecular formula for NF3, atom placement NF3, sum of valence electrons, nitrogen 5 electrons, fluorine 7 electrons. There are 3 fluorine atoms, so 7 electron into 3 is equal to 21 electrons. So remaining valence electrons total 26 electrons. Then you can represent NF3 is like that. Now writing Lewis structure for molecules with one central atom. Column, write a Lewis structure for CCl2F2, one of the compounds responsible for the depletions of the stratosphere ocean. What is your plan? Follow the steps outlined in figures. Step 1, carbon has the lowest En and is the central atom. Step 2 to 4, the other atom placed around it. Carbon has 4 valence electrons, chlorine and fluorine each have 7. The sum is 4 plus 4 into 7 is equal to 32 valence electrons. So make bonds and fill in the remaining valence electrons, placing 8 electrons around each atom. So this is the structure. Now writing Lewis structure for molecules with more than one central atom. Write the Lewis structure for methanol, molecular formula CH4O, an important industrial alcohol that is being used as gasoline alternative in car engines. Hydrogens can have only one bond, so carbon and oxygen must be next to each other with hydrogen filling in the bonds. There are 4 into 1 and plus 4 plus 6, total 14 valence electrons. Carbon has 4 bonds and oxygen has 2 pair of non-bonding electrons. Now writing Lewis structure for molecules with multiple bonds. Write Lewis structure for following: ethylene, the most important reactants in the manufacture of polymers. Nitrogen is the most abundant atmospheric gas. What is the plan? For molecules with multiple bonds, there is a step 5 which follows the other steps in Lewis structure construction. If the central atom does not have 8 electrons, an octet, then electrons can be moved in to form a multiple bond. What is the solution? There are 2 into 4 plus 4 into 1 is equal to 12 valence electron. Hydrogen can have only 1 bond per atom. You can write like that. In B, N2 has 2 into 5 is equal to 10 valence electron. Therefore, a triple bond is required to make the octet around each nitrogen. Now resonance, delocalized electron-pair bonding. O3 can be drawn in 2 ways. Neither structure is actually correct but can be drawn to represent a structure which is hybrid of the two. the resonance structure. The resonance structure have the same relative atom placement but different in the location of the bonding and non-bonding electrons pair. Writing resonance structure. Write the resonance structure for nitrate ion NO3 minus. After step 1 to 4, go to 5 and then see if their structures can be drawn in which the electrons can be delocalized over more than 2 atoms. Solution: nitrates ion 1 into 5 plus 3 into 6 plus 1, total 24 electrons. So you can write the structure like that. You can see here. Nitrogenous does not have an octet. A pair of electrons will move in to form a double bond. Now formal charge. Selecting the base resonance structure. An atom owns all of the non-bonding electrons and half of bonding electrons. So formal charge of atom is equal to valence electron minus unshared electrons plus half shared electrons. Now look at the bosons. For atom OA, valence electron 6, non-bonding electrons 4, bonding electrons 4 into half is equal to 2, formal charge 0. Now atom B, valence electron 6, non-bonding electrons 2, bonding electron 6 into half is equal to 3, and formal charge plus 1. And oxygen C, valence electron 6, non-bonding electron 6, bonding electrons 2 into half is equal to 1, formal charge minus 1. So resonance, 3 criteria for choosing the more important resonance structure. A smaller formal charge, either positive or negative, are preferred to larger charges. A void-like charge plus plus or minus minus on adjacent atoms. A more negative formal charge should exist on atom with a larger electronegative values. So NCO has 3 possible resonance form, A, B, C. You can see formal charge minus 2 0 plus 1 minus 1 0 0 0 0 minus 1. So forms B and C have negative formal charge on nitrogen and oxygen. This makes them more important than form A. Form C has a negative charge on oxygen, which is the more electronegative element. Therefore, C contributes the most to the resonance habit. Now, writing Lewis structure for exception to the octet rule. Write the Lewis structure for S3PO4 and BFCl2. In A, decide on the most likely structure. Draw the Lewis structure for molecules and determine if there is an element which can be exception to the octet rule. Note that A contains P, which is a period 3 elements and can have an expanded valence shell. What is the solution? S3O4 has 2 resonance forms and formal charge indicate the more important form. So lower formal charge more stable. BFCl2 will have only one Lewis structure. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.